Hello, and welcome to this video on trigonometric substitutions. We're going to find the integral of dx over the square root of x squared minus x squared by using a trigonometric substitution. And what's behind the trigonometric substitution is a trig identity that reads as follows. We have cosine squared of theta plus sine squared of theta equals 1. So when we multiply everything by a squared, we get a squared cosine squared of theta plus a squared times sine of theta equals a squared. And then as we do a squared, take away a squared times sine of squared of theta, forgot the square there, we get a squared cosine of theta, that is squared. So that the square root of a squared minus a and then times sine of theta, all that's squared. And then everything we wrote under the root is equal to a cosine of theta as long as we keep certain theta between certain bounds. So if we make x equals a sine of theta, then the square root of a squared minus x squared is a times cosine of theta. So when we use trigonometric substitution, we want to get rid of the root. And if x is a sine of theta, then dx is a times cosine of theta d theta. Then the integral of dx over a squared minus x squared under the root is equal to the integral of a times cosine of theta d theta over a times cosine of theta. And a times cosine of theta cancels out. We have a cosine of theta over a cosine of theta, so we end up with just d theta. And this integral is theta because the integral of 1 is theta. And from x equals a times sine of theta, we have that x over a is sine of theta, so that theta is the inverse sine of x over a plus some multiples of 2 pi that we're not really going to care about. So we have the arc sine of x over a plus a constant c that we always add when we have an indefinite integral. This way we can show that the integral we were given is arc sine of x over a plus a constant c. Trigonometric substitutions rely on trigonometric identities. In this case, we get to use the fundamental trigonometric identity, the one right here, to use the substitution x equals a sine of theta. In general, when we see the expression root of something squared minus variable squared, we want to use the substitution a equals a times sine of theta to get to a trigonometric integral, and we take it from there. All right, that's all for this example. Thank you for watching. Bye-bye.